Okay, so hello and welcome back. So now we have a couple of questions here. So suppose that you have a circuit. These are basically the questions that are related to end of this whole section or this whole chapter, you could say. Basically, these are the end of chapter. The end of chapter exercises related to DC. So if you can answer these questions, that means that you understand DC well enough that you can basically move to the other parts, to the next parts of the book. So for example, suppose that you have a circuit over here. Your circuit is something like this. So you have basically it's a series. You have two resistors in series, and this goes back to your power supply. Okay, so this is your V of S, this is your R1, this is your R2, and you have basically, you put a voltmeter on these points, and this becomes basically, for example, your V1, this becomes your V2. Okay, V1 and V2. So so now in this circuit, suppose that, for example, your R1 is 12 ohms. Your R1 is 12 ohms, and your R2 is, for example, your R2 is 36 ohms, and your V of S is 24 volts. Is 24 volts, and of course your voltage is, as you know, is DC voltage. So you want to calculate your R of T and I, for example. Your R of T and I. R of T and I. So one thing that you need to know about these circuits is that, well, I'll tell you everything that you need to know about these circuits, about basically a series circuit. So first of all, your R of T, when you have two resistors in series, is basically R1 plus R2, that you already know. So that's equal to, for example, 12 plus 36, which is equal to 48 ohms. So R of T is equal to 48 ohms. Now, the current that is going through this circuit, when you want to calculate the current that is going through this circuit, basically this is the current going through this circuit, and this current is basically going through this resistor. The same current is going through this resistor, and the same current is going through your power supply. So the same current is just circulating all around your circuit. So what that means is that if you calculate, basically, suppose that you had, for example, 10 resistors over here, for example, something like this. Suppose that you had one resistor over here, another over here. There you had one resistor in parallel, for example, with this resistor, another resistor in parallel with this resistor, then I don't know, some resistor, for example, over here, and some resistor over here, something very complicated network of resistors, and then the power supply was basically connected to, for example, this point and this point over here. So this would be your V of S, and this would be, for example, R1, R2, R3, for example, R4, R5, and R6. Okay. and of course the current going through this circuit is, of course, in this case it's not going to be that straightforward as in the case of this circuit over here, because this is just two resistors in series, but these are a couple of resistors, some in parallel, some in series, so you need to basically find out what these resistors are. Now the way that you could basically find out the total current going through your circuit is that you would need to basically regard all of these resistors as just one resistor, meaning that you would have to find the total resistance or the equivalent resistance related to all of these resistors all together, and then regard all of them as just one resistor, for example R of T, and then connect this resistor to your power supply, and then this would be your V of S, and then using V is equal to IR, this would be basically V of S in this case, this would be R of T in this case, and then you could calculate the current going through your circuit. So that's how you would approach almost any circuit really. And you want to know what sort of current what sort of current you have over here. You need to do this kind of thing, and then of course this current, if I call it I of T, comes over here, and then it goes into different branches. So it goes over here, and then from here, then again you have these branches, from here you have these branches, and so on and so forth. But basically you need to, no matter how many resistors you have here, you have to regard them, you have to somehow find the equivalent resistance of all of these resistors, and then use that value of resistance in the circuit to find basically the total resistance, the total current going through the circuit. That's basically one thing. So I'm going to do the same thing over here. I'm going to basically come over here, and basically what I'm going to do is that basically, since I know that R of T is equal to 48 ohms, then basically I know that V is equal to IR, Ohm's law. So I can, instead of V, I can write V of S is equal to, for example, I of, if you call this current I of T, for example, then you can write it as I of T times, for example, R of T. Basically R of T is the equivalent resistance of these two resistors. So R of T, meaning that you can imagine that instead of these two resistors, you had just only one resistor with the value 48 ohms connected exactly between these two points, between this point and this point. So I can use now, based on the Ohm's law, I can write the relationship, and then V of S is equal to, for example, 24 volts. So I can write 24 is equal to I of T times basically R of T, which is 48 ohms. 48 ohms. And you need to make sure that, of course, all of these are in ohm and volt and not in some other unit, so that you get the right result for your current. So then this becomes 1, this becomes 2. That means that I of T is equal to basically 1/2 amps. 1/2 amps. This current going over here is 1/2 amps. And that's basically all that we are looking for. So I is equal to 1/2 amps, and R of T is equal to 48 ohms in this circuit. I'll take my answer here. Is 48 ohms and 0.5 ampere. Okay. So now let's say that you have the exact same circuit. Say that you have the exact same circuit over here, and this circuit you have R1 You have R2, you have V of S here. This is positive, this is negative. And let's say that your R1 is equal to, for example, your R1 is equal to 1 kilo ohm, and your R2 is equal to 3 kilo ohm, and your I is equal to 5 milliamp. Is equal to 5 milliamps. So that means that the current going in this direction, of course we are using, as you know, the conventional current flow. Based on the conventional current flow, the current going in this direction is I is equal to 5 milliamps, and your R1 and R2 is 1 kilo ohm and 3 kilo ohm, and your power supply you don't know the value of. So you want to calculate basically the voltage across this resistor here, and the voltage across this resistor. So if I call this, for example, V1, and if I call this V2, this is the voltage across this resistor. This is the voltage across R2, call it V2. So you want to calculate V1, you want to calculate V2, and you want to calculate V of S. And one thing that you need to pay attention to in this kind of circuit is that in a series circuit, basically V1 plus V2 is always equal to V of S, meaning that the voltage drop across R1 plus the voltage drop across R2 is equal to the voltage that the power supply is supplying to the circuit, basically. So in order to calculate these values, so of course, for example, to calculate the voltage drop across R1, for example, what you need to do is you can use the Ohm's law. So for example, V is equal to IR is what you would use, and you need to know that the current going through the resistor, which is 5 milliamp, and you need to know the value of the resistance over here, which is 1 kilo ohm. So if I is equal to 5 milliamp, and if R1 is equal to, for example, 1 kilo ohm, right? So if you multiply these together, you would get the voltage drop across this resistor, not anywhere else, but just the voltage drop across this resistor, which is V1. So I can write basically V1 is equal to I times R1. Of course, something again that you need to pay attention to is that you cannot just take this equation and just apply it. I mean, maybe you could. I'm not saying that you cannot, that you definitely cannot do that in any other case. But provided that your circuit is exactly working like this, the same configuration and the same type of circuit. But you cannot just take this relationship. Of course, this can be applied to all electric circuits or all electronic circuits, provided that, of course, you use it right. If you use it wrong, it will give you wrong results. But for example, the relationship that I have written here based on the Ohm's law, you cannot just take it and use it for some other circuit. You need to know what you're doing. And that kind of thing, what I mean by you need to know what you're doing, that kind of thing you learn either by, well, of course, learning the whole I mean, all the necessary theories related to these series and parallel circuits, which is not much really. Or the way that I happened to learn it was that when I was like, I don't know, 15, 16 years old, I used to just simply play with these circuits. I used to make electronic kits and that sort of thing. And then later on, electronics happened to be my job. So while I was doing things, I kind of picked up on all the different pieces of the theories that go into that go into an electronic circuit. Which, of course, that route is probably not available to everyone. I just happened to do that. I didn't really plan it or anything, and it's not really possible to plan that sort of thing. But what you can do is that, well, of course, as you're basically reading about the theory of electronics in this book or in other books, and probably as you're watching these videos, then you will, over time, you will learn the theory of electronics, and then you will kind of hopefully develop some sort of intuition for these circuits, and then you will know what to do in different situations. So that's basically how you know how to use a formula. One more thing that you can, well, that's I suppose that's enough for this part. I don't need to talk more about this. So now I want to calculate V1. So V1 is I times R1. So I can write it as, for example, 5 milliamps. I can write it 5 into 10 raised to the power negative 3 amps, and 1 kilo ohm I can write it as 1 into 10 raised to the power 3 ohms. Of course, you can multiply them together as well, because kilo and milli will simplify together, but that might actually confuse you. So then V1 would be equal to I, which is 5 into 10 raised to the power negative 3 times 10 raised to the power 3, which is equal to, and of course this is going to give you the voltage in volts, because this is in amp and this is in ohm. So these two will cancel out, so that's basically 5 volts. So V1 is equal to 5 volts. V1 is equal to 5 volts. Now V2, again, you can do the same thing. V2, you can do the same thing. The current going through the circuit is 5 milliamps, and R2 is 3 kilo ohms. So the current is basically 5 milliamps, and the R2 is basically 3 kilo ohms. So again, you can write V2 is equal to I times R2. And so V2 is equal to I, which is 5 milliamps, which is 5 into 10 raised to the power negative 3 amps, into R2, which is 3 kilo ohms, which is 3 into 10 raised to the power 3 into 10 raised to the power 3 ohms. So this is 3 into 10 raised to the power 3 ohm, and this is 5 into 10 raised to the power negative 3 amps. Okay. So then these two will cancel out, and that is 5 times 3 is equal to 15 volts. So V2 is equal to 15 volts. V2 is equal to 15 volts. Now, you wanted to calculate V of S. Since it's a series circuit, you can say that V of S is equal to V1 plus V2. And so V of S is equal to 5 plus 15, which is equal to 20 volts. So the power supply voltage is 20 volts. 5 volts is dropped across this resistor, 15 volts is dropped across this resistor. And you can see that basically the voltage drop across this resistor is 15 volts, 3 times the voltage drop across this resistor, that's 15, is 3 times 5. And as you can see, the value of the resistance of R2 is also 3 times the value of the resistance related to R1. So R1 is just 1 kilo ohm. Basically R2 is 3 kilo ohm. So there is some relationship, meaning that the voltage is being dropped proportionally between the two resistors depending on the value of the two resistors. Okay, so that is that. If you understand these few circuits that we do here, then there is practically no other type of situation that you could basically come across in electronics, at least in simple electronics. And when circuits get a little bit more complicated, of course you might need to know a couple more techniques, but dealing with basic simple electronics, working with radios and things like that, this is all that you need, all that you need to understand, really. Okay, so now suppose that you have the exact same type of circuit, meaning this circuit over here, you have your V of S over here in this exact same orientation, R1 over here, R2, both in series. This would be your V1, V2. The only thing that we change here is these values, basically. So suppose that, for example, now your R1 is equal to 12 kilo ohm. Suppose that your R1 is equal to 12 kilo ohm and your R2 is equal to 8 kilo ohm and your R2 is equal to 8 kilo ohm and your VFS is equal to 24 volts. Now what you want to find here is V1 and V2. Okay, so now in order to calculate these two voltages, you want to calculate basically V1 and V2. So basically you have these two resistors connected in series, and then you have a power supply voltage of 24 volts, and you want to calculate the voltage drop across these two resistors. So what you need to do is that basically you have one resistor over here, another resistor over here, and this is connected to some power supply over here. Now this power supply is 24 volts. V of S is equal to 24 volts. Suppose that this is R1 is equal to, for example, 12 kilo ohm, and R2 is equal to 8 kilo ohm. R2 is equal to 8 kilo ohm. Now the current going through this circuit is going in this direction, and well, of course, since it's a series circuit, basically the same current is going through R1, the same current is going through R2, and so on and so forth. So, and if you want to calculate V1, which is basically this voltage over here, this is V1, and this voltage over here is V2. So to calculate this voltage here, we need to use basically the Ohm's law. V is equal to IR. So you can write V1 is equal to I, which is basically the current going through the whole circuit, times R1, for example. So now basically I need the value of R1 and also the current going through the circuit. Okay. Now to calculate the current going through the circuit, how I can calculate that is that, of course, again I have to use the Ohm's law. V is equal to IR. And And of course, in the Ohm's law, I have one resistor, one current, and one voltage. So the voltage over here, V of S, would be basically my V. The current is basically the current, and the resistance is basically the equivalent resistance of these two resistors, which is basically, you can call it R of T, for example. Equivalent resistance of these two resistors. And of course, you know that R of T in this circuit is equal to R1 plus R2. So that's 12 plus 8 is equal to 20 kilo. So your R of T is equal to 20 kilo. So what that means is that basically then V of S, which is 24 volts, is equal to basically the product of the current and the resistance. So your current, you can write it as the current, and your resistance is 20 into 10 raised to the power 3 ohms. That's 20,000 ohms, or 20 kilo. So your I is equal to, you can simplify this, divide by 210, divide by 212, divide by 26, divide by 25, and so I is equal to basically 6 divided by 5 into 10 raised to the power 3, which is 6/5, which is 6/5 into 10 raised to the power negative 3, which is equal to 6/5 into 10 raised to the power negative 3. 6/5 is the same thing as 6/5 is the same thing as, I suppose, 6 divided by 5 is the same thing as, I'm sorry, I wrote this wrong. 6 divided by 5 is the same thing as, you can write it as 1 times 5 is equal to 5, so you have 1 over here, 0, and 2 times 5 is equal to 10. So that's 1.2. That's 1.2 into 10 raised to the power negative 3 amps, which is the same thing as 1.2 milliamps, right? So the current in the circuit becomes 1.2 milliamps. 1.2 milliamps, which is a very small current. Now, so now that you know basically the value of the current going through the circuit and the value of each of these resistors, you can calculate the voltage drop across any of these two resistors. For example, V1 would be I times R1, which is equal to I, which is basically 1.2 into 10 raised to the power negative 3 amps, times R1, which is basically 12 kilo. So 12 into 10 raised to the power 3 ohm. These two will cancel out, and then you will have 12 times 4 is equal to 144 with 1 decimal point, which is 14.4 volts. So V1 is equal to 14.4 volts. V1 is equal to 14.4 volts. Now, you don't really need to calculate V2 as well, because since it's a basically series circuit, you know that V of S is equal to V1 plus V2. So then you can write 24 is equal to V1, which is 14.4 minus plus V2. So that means that V2 is equal to 24 minus 14.4. So that's basically 10 and 9.6 volts. V2 is equal to 9.6 volts. So then these two voltages added together, 14.4 plus 9.6 must give you 24 volts, which is your supply voltage. So okay, the answer is correct. Now suppose that, let's do another one of these circuits. Suppose that you have basically some V of S 36 volts. Suppose that you have some V of S 36 volts, and you have some current 250 milliamps. I is equal to 250 milliamps, and V1 is equal to 6 volts. V1 is equal to 6 volts. And you want to calculate the R2. Okay, R2 is equal to 1. So you have basically, since you have V1, you know that there must be some R1 in the circuit as well, because this is the voltage drop across the R1, your first resistor. And there is a second resistor as well. So I call this, for example, R1. I call this R2, and these are connected in series, connected to a power supply. So this is V of S, which is 36 volts. 36 volts. Now the current going through this circuit is equal to 250 milliamps. And the voltage drop across this resistor is 6 volts. V of 2 is equal to 6 volts. So it's easy to calculate the value of R2, because you know that V of S is equal to basically V1 plus V2. This is actually V1. Sorry, this is V1. So this is V1 plus V2. V of S is equal to V1 plus V2. So V of S is equal to 36 volts, and V1 is equal to 6 volts. So plus V2. So that means that V2 is equal to 30 volts. So V2 is 30 volts. So since the voltage drop across this resistor is 30 volts, what that means is that you can use the Ohm's law. So V is equal to IR, and the voltage drop across this resistor is V2, is the current going through the circuit times the resistor, which is R2. So so now V2 is equal to 30 volts, right? 30 volts, and the current is 250 milliamps, meaning that 250 into 10 raised to the power negative 3 amps times R2. That means that you can divide by 10.3, divide by 10.25, and so R2 is equal to 3 divided by 25 into 10 raised to the power negative 3, which is the same thing as 3 by 25 into 10 raised to the power 3 in ohms, basically. That is the value of R2. Now 3 by 25 is the same thing as 0.12. So that's 0.12 into 10 raised to the power 3 ohm, which is the same thing as 120 ohms. That is the value of R2. $120 ohms. Exactly. Now suppose that, for example, Now let's say that we have another circuit here, essentially the same circuit, but we want to do something else with it right now. So I have one in R1 over here, R2 over here, and I have my V of S over here, R1 and R2, and there is of course V1 and V2, the voltage drops across these two resistors. And suppose that your R1 is equal to 12 ohms. This is 12 ohms, and your R2 is 36 ohms. And V of S is equal to 24 volts. Right? So now what you want to do, you want to find the power dissipated by each resistor, and the total power delivered by the source. So of course the power dissipated by each resistor, if you have the power dissipated by this resistor over here, by R1, and the power dissipated by R2, if you add them together, you will get, of course, that must be equal to the power delivered by the source, right? So the power delivered by the source, basically we said that P is equal to V times I. So if you have these two resistors over here, R of T is going to be equal to R1 plus R2. So R of T is equal to 12 plus 36 is 48 ohms. 48 ohms, right? Now so the current going through the circuit is going to be V is equal to IR. So V is 24 volts is equal to I times 48. So that is basically 1, and that is 2, and so I is equal to 1 to 2, I is equal to 1/2 amps. So your I is equal to 1/2 amps. Now the power delivered by your source, therefore, is going to be the power delivered by your source is therefore going to be V times I. So your voltage is 24 volts times 1/2 an amp. 24 volts times 1/2 an amp. That's equal to 12 watts. This is the power. This is the power delivered by the source. Now the power delivered by the source is 12 watts. And then that power has to be dissipated in these two resistors. So again, you need to basically use the same relationship, but now this time you need to use it in a slightly different way. So for example, let's say that the current going through this circuit is 1/2 an amp, right? So basically, if you want to calculate the voltage drop across R1, which you can call basically V1, for example. So V1 is going to be equal to V is equal to IR, right? So then V1 is equal to I, which is the current going through the whole circuit, I times basically R1. So then V1 is going to be equal to 1/2 times 12, which is equal to basically 6 volts. So 6 volts is being dropped across this resistor. So V1 is equal to 6 volts. Since V1 is equal to 6 volts, of course the rest of the power supply voltage is going to be dropped across the other resistor, meaning that 24 minus 6 is equal to 18. So V2 is equal to 18 volts, because 18 plus 6 is equal to 24 volts. 18 plus 6 is equal to 24 volts. Because you know that V of S in this circuit is equal to V1 plus V2, right? So your voltage drop over here is 6 volts, across R2 is 18 volts. That means that if you take a voltmeter and place your leads across, or place your probes across the R2, you will read 18 volts. If you put your voltmeter across R1, you will read 6 volts. Okay? Now, we want to find the power dissipated across each of these resistors. So, let's call this, for example, P1, the power dissipated by R1, let's call it P1, is equal to I, which is the same for the whole circuit, times V1. So P1 is equal to 1/2 times 6, which is equal to 3 watts. And by the same logic, P2 is equal to I times V2, which is equal to 1/2 times 18, which is equal to 9 watts. Now 9 plus 3, as you can see, is equal to 12 watts. So then basically 3 watts, 9 watts, and 12 watts. And of course, you can see that over here, this resistor has to dissipate 3 watts of power. It has to dissipate 3 watts of power. This resistor over here has to dissipate 9 watts of power. So then you have to choose your resistors accordingly, meaning that the power dissipation capability, the power dissipation capability of your resistors must be accordingly chosen. For example, if you place a half watt resistor over here, it will burn in probably 10 seconds or so. Or over here you need at least a 10 watt resistor or so. And I would even, I don't really know if there is, for example, a 12 watt resistor. I don't think that you would find that, but 10 watt is something that you can find. So that's basically that. Okay. Now, the next questions that we have, these are 3 questions, and in these 3 questions, use the circuit shown in figure 1.21. Find the unknown using the given values. Okay, so now about these questions, you have essentially some circuit with basically 2 parallel resistors. We have basically one R1 over here, for example, and another resistor here, R2, both parallel, connected to a power supply. So yeah, you have basically one R1 and then an R2. Then this is I1, this is basically I2, and this is your V of S, and of course there is your I over here. So this is your I, basically the essentially the current that goes through your power supply. And then when this I basically gets to this point, it becomes I1 and I2 in 2 branches, and then again this goes this way and this goes in the other branch, and then again they come over here, and at this point again they basically join together to create I. So I basically is going in this direction. So now suppose that, for example, your R1 is 6 kilo ohm. Your R1 is equal to 6 kilo ohm, and your R2 is 12 kilo ohm. Your R2 is equal to 12 kilo ohm, and your V of S is equal to 20 volts. Okay. Now what you want to calculate is R of T and I. So it's not that complicated. You want to calculate R of T and I. So to calculate R of T, since these are basically parallel resistors, your R of T is going to be R1 times R2 over R1 plus R2. Or you can use this relationship 1 over R of T. 1 over R of T is equal to 1 over R1 plus 1 over R2, which you can write as R1 times R2, and then that would be equal to 1 over R of T, and then you would get R1 plus R2, and then if you basically take the reciprocal of this side of the equation, you get R of T. The reciprocal of the other side, R1 R2 times over R1 plus R2. Okay, which is basically what I've written over here. So either of these equations you can use. This is easier, of course. So then R of T is equal to R1 times R2, and both of these are in kilo ohm. So you can just, you don't have to basically convert back to ohm, and R of T you would get in kilo ohm as well. So 6 times 12 over 6 plus 12. This is plus 12, 6 plus 12, which is equal to 60 and 72 divided by 6 plus 12 is equal to 18, which is the same thing as divide by 2, 36 divided by 2, 9, and 36 divided by 9 is equal to 4 ohm. So your R of T is equal to 4 ohm. This is 4 ohm. And then if you use the basically V is equal to IR, the Ohm's law, you have a resistor over here, the equivalent resistance over here is 4 ohm, and the power supply voltage is 20 volts. So 20 volts is equal to basically I times, and of course I'm sorry, this is kilo ohm, right? So 4 kilo ohm, so 4 kilo ohm, which is equal to 4 into 10 raised to the power 3 ohm. So that is 4 into 10 raised to the power 3. Now you can divide this by 4, you get 1, divide by 4 you get 5. So I is equal to 5 divided by 10 raised to the power 3, or 5 into 10 raised to the power negative 3, basically amps, which is equal to 5 milliamps. So the current going through the circuit, this current is 5 milliamps, and basically your resistor, the equivalent resistance here is 4 kilo, and that was number 6. The answer is correct. Now imagine that you have the same circuit, the exact same circuit, the power supply coming to two parallel resistors. Two parallel resistors here. And so your V of S, you have R1, you have R2, you have I over here, you have basically, this is I1, this is I2, and that's basically your whole circuit. And suppose that your I is equal to 2 amp, and your R1 is equal to 10 ohms, and your R2 is equal to 30 ohms. So now what you want to do is you want to calculate the current I1 and I2. So if you calculate the current for one of these, basically if you find one of these currents over here, you can't find the other one because you know your I. Now since you know that this I, this current, comes to this point, and it will be basically it will be branched into two branches, I2 and I1 over here. That means that I1 plus I2 is equal to I, because it's a parallel circuit, right? Because it's a parallel circuit, I1 plus I2 is equal to I. So now in order to calculate the current going through this resistor, you can use the Ohm's law. V is equal to IR. So V is the voltage that is present across these 2 points on this resistor, which is the power supply voltage. And which I don't have. I is the current going through this resistor, which I don't have, and R is the value of resistance of this resistor, which I have. So I have two unknowns. I cannot find any of these values this way because I have two unknowns. So what I need to do is that we said that basically the power supply voltage, basically you know that the power supply voltage is across both of these resistors. So across R2 you have V of S, across R1 you have V of S. So for basically for basically R1 I can write basically V is equal to IR, right? So that means that the voltage across the resistor, which is essentially V of S, is equal to the current going through the resistor, which is I1 times R1. Now for R2 I can write the same thing, V is equal to IR. Now V of S, basically the voltage, V is basically the voltage present across the resistor, which is V of S. I is the current going through the resistor, which is I2. And R is the resistance of that resistor, which is R2. Now you see that if I call this equation number 1 and if I call this equation number 2, this is V of S is equal to I1 R1, this is V of S equal to I2 R2. That means that, so since V of S and V of S are equal here, then I can write I1 R1 is equal to I2 R2. And that's basically the same relationship that we had before, which we wrote as basically I1 to, for example, I2 is equal to R2 to R1. So if you rearrange this equation, meaning that I1 R1 is equal to I2 R2. So if you divide by I2, for example, you will get I1 R1 divided by I2 is equal to I2 R2 divided by I2, and then these two will be cancelled out, and I divide by R1 as well. So R1 I divide by R1 as well, so I will get, and these two will be cancelled out, so I'll get I1 over I2 is equal to R2 over R1, which is what I have written over here. You can write it this way or you can write it this way. It's basically the same thing. So now using this relationship, and of course you need to know that basically I1 plus I2 is equal to the total current, or I, basically, because this I comes all the way up to this point, and then it will be basically divided into these two branches. So if you add these two branches together, you'll get this current over here. So now if I want to use this relationship here, the problem is that I don't know my I. Basically I1 is unknown, I2 is unknown, R1 and R2 I already have them over here. These are R1 and R2, so again I get two unknowns. So now what I need to do is somehow eliminate one of these unknowns. For example, instead of I1, I can write, based on this relationship, I can write I1 is equal to I minus I2. So instead of I1, I can write in this relationship, I can write I minus I2. And I is something that I already know. So I minus I2 over I2 is equal to R2 minus R2 over R1. Now using this relationship, now I can calculate my, for example, I2. So I can write I minus, basically I, which is 2 amps, 2 minus I2 divided by I2 is equal to R2 to R1. So R2 to R1 is 30 to 10, which is equal to 3. So 3 times I2, if you cross multiply, you get 3 times I2 is equal to 2 minus I2, which means that 3 times I2 plus I2 is equal to 2, which means that 4 times I2 is equal to 2. Divide by 2, you will get 2 and 1. So I2 is equal to 1 to 2. So I2 is equal to 1 to 2, or 1/2 amps. I2 is equal to 1/2 amps. And then of course using this relationship here, this relationship you can find the other current. So we said that I1 plus I2 is equal to I. So I1 is unknown, I2 is 1/2, is equal to I, which is 2 amps. So since this is 2 amps and this is 1/2 amps, then you will have 1.5 amps over here. So I1 is equal to 3/2 amps, or 1.5 amps. So this is I1 and I2. So you will get 1.5 amps as I1 and 1/2 amps for I2. And you can see that basically I1 is 1.5 amps, this is 1.5 amps, and this is 1/2 amps, and the value of this resistor over here is 10 ohm, the value of this resistor over here is 30 ohm. So this is 30 ohm, this is 10 ohm over here, the resistor. So through this resistor, through the 10 ohm resistor, the current is 1.5 amp, and through this resistor you will have half amp. You can see that as the you can see that basically the value of this resistor is 1/3 the value of this resistor. 1/3 the value of this resistor, but the current going through that is basically 3 times the current going through this resistor over here. So the lower the value of resistance, the higher the value of the current going through that resistor, and vice versa, of course. So that's basically this circuit, for example. Okay, so I'm going to end this video here, and in the next video we will continue with these examples. I'll see you in the next video. Thank you.